Hi everyone, so for this topic we're looking at 3 ways to find area of a triangle. Now this might seem something that was something that was covered in middle school, but there's a few formulas that we might not have seen before in Math CST. So one that is familiar to us is base times height divided by 2, but we can only do that when a right angle is given somewhere in the triangle, or perpendicular measurements are known, or I would say to my classes, an altitude is given. There's 2 other formulas that you should be mindful of in this course. The other one is AB sine c over 2, and this is to be used when 2 sides of a triangle are known and the angle in between those 2 sides. So not any old angle, but an enclosed angle. So that's the angle that's between two known sides. For the third formula, which many teachers are reminding their students is called Hero's formulas or Heron's formula, depending on how you interpret history. This is a way to find the area of a triangle when all 3 sides are known, but none of the angles is known. So that formula is to be taken the half perimeter first, and the half perimeter is given by the letter S in our curriculum, although some folks use the lowercase p, so that's all right as well. A, B, and C in this formula are the lengths of the 3 sides. Now this one is the most commonly implemented both in the long answer and as a multiple choice or short answer question on the CST exam. More often than not, we're seeing questions where a triangle is given on the page with 3 sides and the short answer question says to the nearest centimeters squared, what is the area of the triangle? And that's your chance to use Hero's formula. So let's look at these 3 triangles below, make some decisions about which formula we might want to use, and then go ahead and solve them. So for the first one, I see that I'm given a base, I'm given a hypotenuse, and I'm given 18 degrees. Now I've said hypotenuse, but actually I've kind of made a mistake in saying that because nowhere in the triangle does it indicate that this is a right angled triangle. It looks like one, but it might not be. It might be 89 degrees or 90 degrees here in the corner because there's no right angle measurement given. So we can't make that interpretation at all. What we do have is 2 sides and an enclosed angle. So I would highly recommend using the second of our formulas, which many teachers call the trigonometric formula. So to find the area here, I'm going to use that. So the area of a triangle, AB sine of c over 2. Now you don't have to worry about the letters of the alphabet so much as that lowercase a and b, and all lowercase letters for triangles are sides. Those are sides, and the capital C refers to the angle between those 2 sides. So here we go. And you're multiplying these guys together and then dividing your numerator by 2. It's a little wonky handwriting, but that's okay. So I've got 12, and make sure your calculator's in degrees. Sometimes I have students who don't have them in degrees, and then, you know, you've got a very strange answer. When I put this in my calculator, I get an area of approximately 16.69 meters squared. So I'll just redo that to double check. I'll just redo your answer. 12 times 9 times sine of 18 equals 33.37 divided by 2, 16.69. For the second triangle that we're seeing here, I notice that we do have an altitude given. So for most of us, that would really indicate that we're going to use the first formula, and one that we're really familiar with from grade 9, which is base times height divided by 2. Now, the base has to be the entire base of the triangle, so this 10.5 is this entire base of the triangle. And so here we go. 10.5. Our height, 6.8, divided by 2. And that's 35.7. And don't forget to put your units, which is great. Now in this last triangle, which is the kind we most often see on the exam, you are given 3 sides and no angles and no altitude. So that makes it, at least on the surface, difficult to solve. Don't make the mistake of using base times height divided by 2 here, because it looks like a right triangle, but unless it's indicated, you can't make that presumption at all. So for this, I'm going to use Hero's formula. Now, what I'm going to do first is find out the half perimeter. And by half perimeter, I mean that we add up all the sides, 3 plus 6 plus 5, and we divide that by 2. And we find out that that value is 14 on the top divided by 2 gives us 7. So that's our value of S. Now we can use our formula, Hero's formula, as you can see up top. And we're going to put all sorts of stuff under the root. So I'm going to make a big long one. Make sure everything you're capturing is under the root. So it says 7. Then 7 minus one of the sides. It doesn't matter which one's A, B, and C. 7 minus 3. 7 minus 6. 7 minus 5. Okay, so you have to use bedmass under the root. So brackets first. 7 minus 3 is 4. 7 minus 6 is 1. And 7 minus 5 is 2. Now, will they always be small numbers like this example? Certainly not. Now, next deal with the bedmass is that you have to multiply 7 times 4 times 1 times 2 under the root. And when we do that, we're going to get the square root of 56. And then you can do the root of your answer. And that answer is approximately 7.48 meters squared. Okay, and that's how you use Hero's formula. And this one, as I say, is the most common standalone area formula on the multiple choice section of the test, and you often need to use it on the long answer questions that I'll go through in another video, and combined with sign law as well.